All right, so here we're on body mass index, and it's of an individual who weighs W pounds and is 8 inches tall. It's given by B equals 703 times W over H squared. Okay, so we're supposed to write an equation showing the relationship between the body mass index and the height of a young teenager who weighs 100 pounds. All right, so we're going to kind of assume we haven't got that equation yet. We're going to kind of work our way down. So let's kind of do this as steps because that's going to help us as we go. So not do steps here. We'll say step one instead of steps. So step one, what are dependent and independent variables? All right, well, dependent variable, well, we're going to have a weight, W, and we're going to have an H, which is our height. Okay, so those are going to be two of the variables. And when we get done, what else are we going to have? We're going to have some BMI index. And, they give that to us as B. And so what else do we need? Well, now we need the independent variable. That's T. And that's going to be in what? Well, let's see. I think it's going to be in years away. It looks here. Yeah, it's going to be per year. So let's call that in years. Okay. All right. So that's step one. Step two then says, two. That means now what we have to do is we have to write an equation. Well, they gave us the equation. So, we're kind of doing this as steps, but part of the steps they do give us 703 W over H squared. Now with this one, we can say, okay, well, now we can solve A because now they say the weight is 100 pounds, and we're going to write an equation with the relationship with W equals 100. Has nothing to do with height, nothing to do with BMI. We don't know those. And so what we're going to do is we're just going to plug in W as 100. So B equals 703 times 100 over H squared. Now we can simplify that. We can take that times that. And so we can say, well, B is equal to 70300 over H squared. And so that is what they're asking for part A. Okay. But that's just plugging in one value, and so that's kind of a side little thing. That's kind of like on another problem where we just had to plug in the girth and then multiply it all out and get a value for the W for our water transpiring. Okay, but now what we really need to do is we need to go to step three. So this was kind of a, well, here's step two. Now let's solve something from step two. Now let's go to step three. And that's going to be differentiate both sides. Now we're going back to our original equation, which was B equals the 703, and let's write it all as one thing, and that way we can kind of see what it is. So we need to take derivative with respect to time of B, and then derivative of this with respect to time, and now we need to take that with respect to the height. So this is going to be of 703W. And let's write this as h to the negative 2 because we're going to bring it up here. It's easier to do that way. And so that's what we're going to take the derivatives on for both sides. So what does that give us? Well, that gives us, that's almost a D. dB dt equals, now the derivative of that with respect to height is going to be a negative 2, and then times 703w, and then h to the negative 3, and then dh dt. Okay, so that works. And so then what do we need to do? Well, we need to kind of multiply that out. So 2 times that's going to be 6, 0, 14. So that's going to be a negative 1406. And then that's the W, and that's over H cubed to put it back into the format it kind of was. And then DH dt. And if we want, we can go ahead and put our dB dt on that side. Okay, so now we've kind of solved the derivative, and so then that means we're on to step 4. Maybe we could put step 4 over here. And step 4, what do we know? Okay, so we've constructed a rates relation equation showing the interconnection of the rates of the change with respect to time and of the body mass index and the height. And so that's what we did. We did it with respect to height. And so now we need to plug in everything we have. Well, we know now the height is 5 feet 3 inches, 100 pounds, and a half inch per year is the growth rate. So let's write all this down. So we know 5 foot 3 inches. Well, 5 feet is 60 plus 3 is 63 inches because we need height in inches. The weight was 100 pounds. And it said the change in height, dH dt, was equal to a half an inch per year. Okay. So we know all of that, and so we can plug that into this equation, and we can solve for the change in the BMI with respect to time. So dB dt is equal to, well, now we have negative 1406 times 100 divided by, and we have the height is 63, and we're going to cube that, and then that's going to be times the 1/2. Okay. So if we plug all that in, negative 1406 times 100 divided by 63 to the third, and then times 0.5, we have a negative, because we have a negative here, so we better get a negative here, 0.2811, blah, blah, blah. So we'll call it a negative 2.81, and then per year, because BMI doesn't have a units. It's your BMI is 34 or 21 or whatever. And so it's going down by 0.281 per year. And so that is going to be our rate of change. Okay. So the BMI with respect to time is going down. Okay, and again, that was very useful because it gave us all that. All we really had to do is take the derivative of this with respect to what they told us to, which in this case was h. And so when we did that, that was pretty easy. Then we just plugged everything in and we got our final answer. All right, so let's stop there and we'll come back with another one.